It is time for our next two speakers, and a joint presentation is coming up. The representatives of Member Group 3 Research are coming up. The annual ProStep IVIP Symposium offers the so-called scientific track, and of course we would like to do so this year as well during our first virtual symposium. And I am pleased to welcome our two speakers. We have one of them right here with me on stage already. Thank you for joining me, Andreas Eiden, live here in the studio. Thank you so much. And since 2016, to give a bit of background information on Andreas, since 2016, he is research assistant at the Chair VPE. The Chair VPE comprises the work soups, Smart Systems Engineering, Smart Systems Lifecycle Management, and researches in the area MBSE, PLM, IoT integration, engineering intelligence, and digital twin. Andreas is head of the working group Smart Systems Lifecycle Management at the Chair VPE, and he works in the areas of PLM, data networking, and AI in product development. So welcome once more, Andreas.
Thank you.
Glad to have you here live in the studio.
Thanks for having me.
Now we have another half digital duo, so to speak, because again, our second member, so to speak, of this presentation will be joining us virtually. And here, as you can see, we already have him for you, ladies and gentlemen, Dr. Julian Shallow. He studied industrial engineering at the Technical University Dortmund, built up the digital manufacturing department at the Institute for Production Systems, IPS short. He has a PhD for the integration of data mining in PLM. He coordinates industry projects for the Institute of Research and Transfer and is founder and CEO of IPS Engineers, software development for the management of complex production systems. And just to explain the connection between the two of you before we move along to the presentation, Andreas as well as Julian were both in charge of the conception of the project AKKORD, networked and integrated application of industrial data analysis for value-creating, competence-oriented collaboration in dynamic value-added networks. You will explain what that means in detail in just a minute. And now it's a long name, right? But we're going to get that explanation right now. Dear viewers, it's now time for me to clear the stage for the joint presentation of the two, which is titled Industrial Data Science, Technical, Organizational, and Human Challenges. And gentlemen, the stage is yours. Or actually, Andreas, should we leave the stage up to Julian?
Of course. He's going to start. I'm going to take over.
All right, then, Julian, the stage is yours.
Yeah, again, a warm welcome from my side. We'd like to do a mixture of our experience from our industrial data science projects during the last more than 10 years. And, of course, some results of our AKKORD project. You mentioned the long name there. But we did not mention the consortium. It's a very huge, interesting consortium here, and all the partners are greeted here. To get it started, what is data science, and especially in industrial data science, all about? For us, it's climbing the North knowledge ladder, and especially the extraction of information and knowledge from data. So the core of data-driven knowledge management there. And as easy as that, industrial data science is just the application of data science in an industrial context, just doesn't make it easier. But of course, with regards to other Industry 4.0 technologies, maybe data science is the most promising and a technology at the moment with big potentials, and we want to really deliver these potentials. I'd like to start with one question to our audience. Are you already on your way to apply data science, or more specific, how present is that topic of data science or industrial data science in your company? We got a short poll prepared, and I'm really interested in hearing your experience. From our point of view, there are two very common ways to approach that topic of industrial data science and praxis. On the one hand, we got a lot of customers who have existing daily problems, and they are searching for solutions for that problems. For example, in the brewing industry, biological, chemical processes, a lot of influences there. You just reach the limits of Lean Six Sigma at one time, and you have to find new methods and ways to solve your daily problems. And on the other hand, there are, of course, companies who just want to be pioneers in data science. They want to explore the potentials of data science. And for example, the world market leader in quality services along the product life cycle did a screening, a product screening with us, where to enhance products or services with data analytics or data science methods. And both ways, interestingly, they lead to one point, to a use case specific IDS project, because in general, you have to show a working application in daily life to get the acceptance. And so really carrying out those industrial data science projects became the core of our business during the last years. And maybe it's possible to have a quick look on our results, how far you are on your way towards data science. Maybe, Afni, it's possible to have it. Okay. Yeah, I think you're quite far, but you're not finished now, and that's what we realized in praxis too. Yeah, and we really asked the question: why are we not applying data science consistently in the industry with those big potentials behind it? And we found out that there, of course, are a lot of barriers, restrictions, and problems in applying data science at the moment. And to put it positive, we figured out three key requirements for successful industrial data science projects I'd like to share with you. First of all, is about the procedure about how to carry out an industrial data science project in detail. And our finding there is that cross-industry standard process for data mining provides quite a well-defined project structure in many cases. And as it is very similar to well-known cycles like the PDCA cycle or the DMake cycle, you can easily accept it from a domain perspective, and it's always crucial to include your domain expert in that process. Nevertheless, there are two really interesting points within that cycle. You can read it here. It's an example from our Siemens X-ray testing. One is after the data preparation. There are quite a lot of projects where we get to a stage where we suddenly get a lot of homework on your data, or even got some showstoppers in the preparation of data. And here, of course, it's a high risk, because you put a lot of effort in a project during those three phases here, and closing down the project or shifting it to the next year because of data homework. That's bad. And even worse, in the deployment stage later on, where you really want to reach your potentials there, we sometimes face some technical restrictions. And those restrictions really sometimes block us from applying the models we created. And we should consider those technical restrictions early in the business understanding here. So key takeaways: have a look at the CRISP DM, care about data quality, and define your use case as well to have a look on the technical restrictions. And as I mentioned, the data, from my personal experience, the data is the most crucial point and the most important key requirement. The maturity of data, it's always the same thing. We go into the first workshop. It's always sums up here with the data. Everything is in place. Our systems are perfect. Our data quality is perfect. And then you dig deeper and nothing is in place. So we came to the point that we needed a kind of tool to assess the maturity of data very early in the project. And we did that based on defined criteria here. You can read them out, but I'd like to really stress those two here. The consistency of data, especially in grown IT landscapes, and the traceability, because that's extremely important for cross-domain data science topics. And those are the really interesting ones here. You can, of course, use this tool in order to assess your initial status, but you can also set a target state there. And by doing this, you will find a new way to ensure data maturity in your company, and you will even find new responsibilities and roles. Yeah? So have a look at those tools, similar like this. Think about cross-functional data mining, and of course, really try to integrate it in your organization. You have to be in the place to have someone responsible for data and data quality. And if we're talking about new roles and competencies, of course, industrial data science is a highly interdisciplinary task. And that interdisciplinary work and performing there is required. And we found that integrating computer science, statistics, and production engineering in that hotspot for industrial data science, that's really hard to find a common knowledge there, and to find the right starting point in your company. Two tips from our side. One is maybe you have some experts from the quality department in Six Sigma, familiar with analysis, deep within the processes. You can really push them, give them way to move towards data science. And the second learning is that the young generation of production engineers, those digital natives, they are really keen in learning more. And you can easily find some of them to be kind of citizen data scientists, to know enough about data science to get a broader approach. What is very positive from a university point of view, that we really recognize that interdisciplinary teams are the key success factor, and we're breaking down those silos there. That's our network at Dortmund. I would guess all universities do at the moment. So consider those competencies, find the starting point, and have a look at the formats from the university, because that's what we are talking about now in the second part of the presentation. It's that triad I mentioned between organizational, technological, and human tasks we have to manage. And that was the starting point. Those three key requirements were the starting point for the advanced research. And so I'd like to pass over to my colleague, Andreas Eiden at Stuttgart.
Okay, thank you for giving this short introduction and for mentioning all those things you have to consider when doing data science. So we thought like, okay, how can we help companies, and especially small and medium-sized companies, to do just this? And then we had the idea to do this with such a model-driven kit that you can use, and where most of all these things are really integrated. As you can see in the bottom, I'm trying to span this over the whole product lifecycle, from the beginning to the end. Everywhere data is generated, data can be collected, data can be analyzed. So we have 4 big points where we can help companies. We're trying to do this. The project is not yet finished. We're right in the middle, planning to finish next year. No, in 2022, sorry. So can you just give you a glimpse of what we're doing? And I'm going to start with one big part of it, which is new collaboration opportunities. Many companies don't see the value in doing data analysis. Many companies, or all companies, have a business model, and so we're trying to give recommendations like, okay, how can you enhance your business model by doing data analytics, and how can you find partners? How does this affect your key resources, like your personnel, like all your machinery or whatever? We're building a recommendation assistant here, and we're doing the same And the next part, which is data analysis modules, many companies have to start over. We saw it in the results of the first question. Many companies have just single projects, but yeah, it's just single projects. It's not a thing that is continuously rolled out. So we thought, like, okay, how can we identify modules that are not only interesting for one company, but how can we do this in a way that there are some predefined things that go in these data analysis modules, and so you can use these predefined modules right out of the reference kit in your own company and do data analysis with this. And the third one is competencies, which is really for SME, it's crucial, because in big companies, it's easy. You probably have a department where you have 10, 15 or more data analysts. You can say, okay, try to find some projects, they have all the competencies, but in small and medium-sized enterprises, they don't have this. So we're trying to give them learning nuggets, small courses, even some bigger ones, that introduce this topic and that introduce this whole reference kit, like how can you combine a new business model with data analysis modules, with data backend, and how can you achieve more value with all this. And then to come to the last one, it's the data backend system, where we're trying to connect all these different data sources that are needed for data analytics. And we see it, data is scattered, and you have to have some experts that make you some, that give you all the data and extract it out of your database as a snapshot. Then you can analyze this snapshot. Why can't we make it easier to get all these data? So this should be the 4 parts of this data-driven kit, or this reference kit. And we, of course, we have something like we want to do all this inside one big platform. We want to have this in the internet. We want to have external services on this side. We want to connect it to all these parts that I just mentioned. We want to give everybody the opportunity to use this as an outcome of this project when it is when it is going to finish in 2 years' time. So how we're doing this, just a short glimpse, because we're very limited on time. We have identified different use cases. Here's one we're doing with Volkswagen. They want to have an overarching predictive industrial engineering, and we're trying to find similarities in labor plans. And these similarities in the labor plans can help to decrease searching time, to decrease doing stuff again and again and again. And we're trying to have these parts and these ideas and these analysis in modules inside our reference kit. Another one, which is, I think, very interesting for many people, is data-driven quality management, which we're doing with Miele. And here you can see in the image we have so many different data sources where all the data comes from, and we have to connect it, and then we want all these people at Miele to build their own analysis and to have their own dashboards where they can use KPIs to monitor the quality situation and learn what they can do with data science. And how do we do this? How do we bring everything together in this reference kit? This is just another view on the reference kit. You see we have the mentioned learning platform, then we have these data analysis use cases where we start with a business problem, then start with databases, data preparations, and so on. We're modeling, we have results, and we're trying to put all this inside this reference kit. And you need, which is also part of the title of the research project, some kind of value-adding network. We cannot do this with just one research institute. We cannot do this with just one company. As you can see, we're 14, or at least in this picture, 13 different partners that are trying to achieve this data science topics inside these different use cases, and we're trying to give all this to other companies as some part of some best practices. So yeah, just a very short glimpse, but because I'm running out of time. Data preparation is one of the crucial things. First, data understanding. I had an interesting talk right before my speech that this is really important. You have to first understand what you're analyzing, and you have to build yourself a data model. Then you have to ask yourself the question, where does the data come from? Is it two different systems, like in this example? And then how can we bring these systems together technically, and can we enrich all these information with maybe more information that is useful in another data analysis scenario? And then also you have these modules, like in data preparation, we have every time the same situation. You have to normalize data, you have missing data that you have to handle, you have outliers that you have to handle, or you have different use cases for data analysis that can be a bit standardized, like in sales, marketing, purchasing, and so on and so on. We're trying to do all this inside the reference kit, but yeah, it's because the time is limited. I want to end my part of this presentation just with the remark that you see data preparation is some huge thing in all this kind of data analytics. And this is one problem where many companies, especially the small and medium-sized ones, say, is this really a thing for us? Is this really something that is adding value for us, or is it just costing us money? And this is where I want to hand over to Julian again.
Yes, and that's an interesting question for us too, and I'd like to ask that question to the audience. What about the return on investment in industrial data science projects? If you would judge your current IDS activities now, how economical are they really? Just give us an idea there, because when we discussed that at ProStep IWIP Association, especially in member group 3 with Professor Stark, we came to the point that with those efforts in data preparation, this will not work out. So we founded that group for data preparation, for data analytics and artificial intelligence back in 2019. And after a short COVID break, now we are in the new normal now. And the good news is there's still room for your input and requirements. We got a lot of supporters now, and contributions from our supporters. Even got some first results, but we want to focus more on standards and tools to extract, load, and transform data in the future. And just contact my colleague, Thorsten Reckelkamp, if you want to join us there. And with a look how economically we are, I would guess there is still some potential at the moment. And that's what we are facing at the industry right now. Of course, there are some really interesting and good examples. One we contribute to is that dynamic value stream analysis in cooperation with Siemens. And that is really based on seamless data acquisition, automated calculation of data, and a very dynamic visualization for analysis based on search machine technology there. So one showcase where the digital twin of production performance really is put in place. And that is a crucial task, especially in complex production systems. And for us as industrial engineers, maybe the task for the future. To sum it up, in our presentation, hopefully you found that industrial data science is a complex and interdisciplinary topic too, and that we have really to support companies there. And I think, Andreas, that's your point too. Eh?
Yes, and we think that we can help companies to do this task with our integrated data-driven reference model kit, which is not yet finished, but will be finished in 2 years' time. So on the next slide, hopefully we can see it, there should be the link to the project site, so feel free to join us and yeah, keep yourself updated.
And if you're interested in the data preparation for data analytics group, just contact us and join us, because that data acquisition and preparation needs more standards, and the ProStep IWeb Association will be the best platform to have it. And one closing remark from my side, that triad we mentioned between organization, human, and technology, that really has to be harmonic, has to be an accord in the future. And we have to be sure that the factory of the future, that factory will remain a socio-technical system, and we have to take care of that. Thank you very much, and I think we are open for questions.
All right, thank you, gentlemen. And yes, we are open for questions, and we're going to get right on that since we only have a few minutes time left. So let me just take it from the first question up. Have you also taken big data into account during your research, gentlemen?
I'm trying to do this in my PhD thesis, which is just at the beginning. So hopefully I can tell you more about this next year, but it's part of this thesis work.
Part of your thesis work. How about Julian?
Yeah, of course. One of our partners, major partners in that project, is RapidMiner, that big supplier of data mining software, and they got a lot of solutions for big data. But to be honest, in many cases we are talking about here, it's not really that volume of data that's crucial, but it's more or less the variety. So other force which make it difficult. Yeah.
All right. Thank you, Julian. Next question up. Is there a secure process to distinguish between the extraction of knowledge and the extraction of coincidence from the analyzed data? How do you tell the two apart? Is this more so a question for Julian?
Yeah, I think so.
Okay.
That's interesting. If I got it right, then of course there's some kind of implicit knowledge within a given join of data in your IT systems. And what we realize is that, of course, the setting of those systems is sometimes a kind of copy and paste setting, and that might be the coincidence. But of course, you can have methods to test it and processes to test it, quite advanced. We are familiar with those processes, but if it comes to AKKORD, that's not our major problem at the moment.
Maybe to add just a single
Sure.
sentence, I think it's also showing, because of this, domain expertise is really important. Data science without domain expertise is not working.
All right, thank you for those closing words. We're going to leave it there because it's now time to move on to our next presentation. Thank you to both of you very much for your wonderful contribution. And if there are any questions left, if anything is still open, then I'm sure that the viewers can ask that question to one of the email addresses you'll find on our landing page, and we will forward that to the two of you. All right, thank you so much.
Thank you for having us.
All the best to you. Thank you for joining us.
Thank you.
Bye, Andreas.
Bye.